Hello everyone, welcome to my class. In today's class, we will study about rational numbers, irrational numbers, and surds. And we will be able to find difference between rational numbers, irrational numbers, and surds. So let's see what are rational numbers. So in general language, we can say that rational numbers are something which can be written as a fraction. Okay, so let's say 3 over 5. This is a rational number. Okay, but there is a condition. Even if they are written in form a over b, that is a fraction, b cannot be equal to 0. It can take any values, any integer, but it cannot take the value 0. Okay, so denominator cannot be 0. Now, let's see. So, we can say what are the numbers that can be included in a rational number. So, integers, all integers are your rational number. Why? See, suppose what are the integers? Integers are all positive and negative numbers. Suppose minus 99 minus 1 and then 0 plus 1 plus 11. So all these are integers including 0. Okay, and these integers they can also be written as um, minus 99 can be written as minus 99 over 1. Minus 1 can be written as minus 1 over 1. Okay, 0 can also be written as 0 over 1. 1 is also 1 over 1. 11 is also 11 over 1. So they take a form a over b where b is not equal to 0. That's why we can include all integers as rational numbers. I hope this is clear to everyone. Now, the second number which can be included as rational number are terminating and recurring decimals. So, what are terminating? Means you have studied it earlier like 1 over 2. 1 over 2 can be written in decimal form as zero point 0.5. Okay, so it is not moving more like after the decimal place just we have one digit and that's it, so it is terminating, we are not getting a repeatedly any number. Okay, now see, recurring. When we say the word recurring means there will be a set of number or a pattern of numbers that will be repeating. Suppose you have 1 over 3. When we write this as fraction, you get 0.333 that keeps on repeating. So, this is a particular number, or you can say this is a pattern which keeps on repeating. That's why this is a rational number. When you have a fixed pattern that repeats, then it is a rational number. For example, you can also say 0.2424. See, this is recurring. It's not terminating, it's not ending, it's recurring. At the same time, you can find a pattern here that every time 2 4 is repeating. That's why this is also a rational number. Now let's see at the third point. All the fractions in the form a over b, where a and b are integers. So we know that fractions are nothing but 2 over 3 and all like that. So all the fractions are also rational numbers. So I hope this is clear to everyone. Okay, let's see few more things about rational number. Now you can see that these are all rational numbers. See, 7 over 10, oh sorry, 7 over 8. This is a rational number. Okay, then 87, it can be written as 87 over 1. So this is a rational number. 0.21, 0.21 is written as 21 over 100. So this is a rational number. Minus 19 upon 4. So minus 19 over 4 is also a rational number because this is written in the form a over b where b is not equal to 0. So this is a rational number. Now, point 0.6 Recurring means point 0.6 keeps on coming. See, it keeps on going. Since there is a fixed pattern, a fixed number that keeps on repeating, so this is also a rational number. And moreover, zero point 0.6 can be written as 2 over 3. That is again a fraction form, and we can say that is a rational number. So I hope this is clear to everyone. What are the things that can be included in a rational number? Now, let's move to irrational number. See, an irrational number is a non terminating. Non terminating means this is recurring, it will not end. Okay, decimal that cannot be expressed as a fraction. So, an irrational number is non-terminating decimal which cannot be represented as a fraction. This is in opposition to the definition of rational number. Yes, irrational numbers are opposite to rational numbers. Okay, now irrational numbers cannot be expressed in the form a over b. Let's see actually what happens. Now, when we saw few examples of rational numbers. So, your rational number can be 0.5555 and that keeps on going. So this is also non-terminating, but you can see a pattern. Or see 0.139139139 that keeps on repeating. So you see there is a fixed pattern that 139, the set of 139 keeps on repeating. So this belongs to rational number. But when we speak about irrational number, look at the pattern here. Irrational number, this is also non-terminating, means this is also recurring, but what happens, you will never find any pattern. So it is suppose 11.3270147 53 and that keeps on going. So you can say that this is non-terminating, or you can say this is recurring, and there is a no pattern. When there is a no pattern and it is recurring, then we call it as irrational number. Okay, and you cannot, because they are non-terminating and there is no pattern as well, so we cannot express it in the form of a over b, right? So let's see, there are few famous irrational numbers. See, pi, we call this as pi. Pi is equal to 3.141 and that keeps on going. Then you have this phi. Phi is also called as the golden ratio and this is 1.618 and that keeps on going. So you cannot find any pattern here, and this is non-terminating as well. And then you have E, that is 2.718, that is Euler's number. This is called as the Euler's number, and here also you won't find any fixed pattern, and this is also recurring, means non-terminating. Now when you look square root of 2, so again we don't have any fixed, like any non-terminating decimal for this, so it is 1.414 and that keeps on going. So I hope this is understood. Okay, now understand it this way. Suppose if you have root 4, root 4 is 2 and 2 can be written as 2 over 1. So this is your rational number. Okay, now when we have to write root 5, see, 1 square is 1, 2 square is 4, 3 square is 9. Now you see that this 5 falls between 4 and 9, but our square numbers are 1 square, 2 square, 3 square. Our square numbers are 1, 4, 9. So this root 5 cannot be written as an this form, as a whole number form. Okay, so this will also come as irrational number. Okay, I hope this is clear. So irrational number are non-terminating decimals. Okay, and at the same time they don't have any pattern, because they don't have any pattern of repetition. That's why they come into the irrational number group. And then we have another thing that is called as surds. Now see what are surds. Again, surds are also a type of irrational number. Okay, and surd is the root of a number which produces a non-terminating decimal. So just now I gave you one example of root 4 and 5. So I said root 4 is rational number, whereas root 5 is irrational number. So it's not only irrational number, root 5 also falls in the category of surds, because in surds when you find square root, cube root, or any root, fourth root, fifth root, sixth root, or any root, you will never find a answer as a whole number. It will be something non-terminating decimal point. That's why they that is irrational number, and in the root or cube form they call it as surds. Okay, a surd is an expression that includes a square root, cube root, or other root symbol. So let's see 3. No, this is root 3. Root 3 is 1.73206, 1.732050807568877, and something keeps on going. You will not find any pattern here. Okay, since there is a no pattern here, so this falls in the category of irrational number. And then when it is in the square root form, we also call this as surd. I hope this is clear. And then pi. Pi is 3.14159 and it keeps on going. So pi is also irrational number. Okay. Now roots that cannot be written as exact decimals are called as surds. Okay. Now see, you can have example of surds like root 90. We cannot write this as exact decimal or whole number form. Then you can also have like root 11. Then cube root of 25. We don't have any value for this, like any exact decimal places. This is also recurring. Then you can have fourth root of 81. Okay. Okay. Now let's see a few questions based on rational, irrational, and surds. Now write whether each of these numbers is an integer or an irrational number. Explain how you know. So, from this group of numbers, root 9, root 19, root 39, root 49, and root 99, we need to identify which are integers and which are irrational number. Okay, let's write their values first. So, root 9 is nothing but 3, which can be written as 3 over 1 form. So, this is rational. Oh, this we have to identify as integer or irrational. So we will say this is integer. Okay. So we don't have to bother about this form. Just we got the value as whole number. That's it. So this is integer. Now root 19. You will not get any fixed value for root 19, and this is not a square number. Okay. So this is irrational. Now root 39. For this also we will not get any non-terminating number or a non-terminating decimal as the answer. So this is also irrational. Root 49 is nothing but 7. So this is integer. And again root 99, we will not get any non-terminating decimal for this as well. So this is also irrational. I hope this is clear to everyone. Next, write the rational numbers in this list. So, rational numbers are the numbers which can be written in fraction form. Okay, so let's see. Root 1. What is root 1? Value of root 1 is 1. So, this is 1 over 1. This is in fraction form. Then 7 and 5 over 12. 7 and 5 over 12 is 12 sevens 84. That is plus 5. That is 89 over 12. So, this is also in fraction form. and then minus 38 is nothing but minus 38 over 1. Root 160 we cannot calculate, and minus 2 square root of 2.25. So let minus be here, and then you know that 215 squared is 225. So this is 2.25, so you can say 1.5 whole square is 2.25. So here when we remove the square root sign, we get here 1.5. So you get minus 1.5. So this is also a rational number. Okay. And then minus 35. You won't get any value of this kind. It will be non-terminating decimal. So which are our rational numbers? So wait, I will shade the rational numbers now. So your rational number is this one. Your rational number is this one, and this one, and this one. That's it. So these are your rational numbers. Now let's move to the next question. Write the irrational numbers in this list. Okay, now you see here 0.333. This is repeating, this is recurring, but you can see there is a pattern, means a fixed number is repeating every time. So this is rational. Minus 16 is nothing but minus 16 over 1. So this is rational. Now you see root of 200. We cannot find the value of root of 200. Okay, so this is your irrational number. Now, root of 1.21, and you know that 11 squared is 121. So 1.21 will be 1.1, and this is rational, and this is cube root of 343. So this is nothing but 7. So we have just one irrational number here, and that is root of 200. Okay, I hope this is understood by everyone. Now, the next one. Explain whether each of these numbers is an integer or a surd. Okay, so we have to find whether these numbers are integers or surds. So explain. Okay, so let's simplify whatever we can. Square root of 100. The value of root of 100 is 10. Cube root of 100. We cannot find. Then square root of 1000, this also we cannot find. Then cube root of 1000, and we know very well cube root of 1000 is 10. Then square root of 10,000, square root of 10,000 is 100. Okay, and then cube root of 10,000, we cannot find this. Now let's mark them as integer or as a surd. So now you see that because we got the value as a whole number, so this is your integer. And here we cannot find the value of this cube root of 100. We cannot get the exact number here. So this is your surd. And then root of 1000. This is your surd. And then this, see, we got the value of cube root of 1000 and as 10. So this is integer. Then root of 10,000, that is 100. So this is also an integer. And again here cube root of 10,000, we cannot find the value as a whole number. So this falls in the category of surds. So this is actually important topic in numbers, and this is the first chapter for grade 7 as well as grade 8. And I must say this is important topic for your lower secondary checkpoint as well as Cambridge International Examination, that international mathematics. So stay tuned, we will come with many more questions, we will solve many past paper questions also. Thank you for watching. Like, share and subscribe.